Hello everyone, how are you all?
Hello, sir. We are good. How about you?
Yeah, I am good. Thanks for asking. I am good. Thanks for asking, Ibrar. All clear till yesterday?
यस सर।
पक्का?
सर आपने जो होमवर्क दिए थे वो भी किया।
चलो बढ़िया. Who has solved the problem? Okay, so let's start today's session. Okay, what was the problem we were discussing yesterday?
सर हैशिंग।
Hashing is the topic that we have taken, right? Who will tell the definition of hashing? Will tell the definition of hashing. What is hashing? Who will tell?
Storing the data in key value pair.
Storing the data in the form of key value pairs.
Key value pair.
What is the inbuilt data structure to store data in this form in Python?
Dictionary.
Dictionaries, right?
Dictionary.
So what was the question we were discussing? Given an array, given an array, given an array, find number of occurrences, find number of occurrences for each element of the array. Okay, tell me who has solved it using brute force?
Sir, I solved it.
Yeah. Can you share the approach?
Okay, sir, I'm sharing in the chat.
Okay. Who wants to share here? How have
Sir,
you
I-
solved the problem? Okay, yeah, Junaid, go ahead.
So you have disabled the test.
Okay, just wait. Yeah, you can share. What have you done? Can you explain?
Yes, sir.
Yeah,
So first I have created an array and an empty dictionary.
yeah.
So then create a method and initializing I is equal to 0 for while loop.
Okay. Then
Then the condition that is I is less than length of array. Then creating a variable count and
Okay.
create a variable a which is called array of I.
okay.
Then I have created a loop for j in range I comma length of array.
Okay.
If array of I is equal to array of j,
Okay.
then increase count plus 1.
Okay, fine, fine.
So then dictionary store the value of dictionary in a that is array of I and then the count.
Okay.
If a is not in dictionary, so means a that we have array of I is not in dictionary keys,
Okay.
then update it, add it, then increase the value of I and return the dictionary after.
Okay, fine. Fine. Getting the correct answer?
Yes, sir, this is the output.
Fine. Okay, fine. Let's see how can
Sir,
we.
is it done by brute force approach?
Yes,
This question.
he is just finding all kind of possibilities. Running two loops, those are at all not required for solving this problem optimally. Okay.
Sir, I also did with some other way. Please tell me it is right or not.
Yeah, this is also correct. This way is better than what Junaid has done. Your way is better. Okay, we will employ this method. Whatever you have done, I will show how can we solve this. Okay, let me share your screen. Let me share my screen. Okay, so let's take Shazia's method. What she has done to solve this problem. Okay, what she has done to solve this problem. Let us see them. Let's see that. I will push both the codes today after the class. Yesterday's 2 pointers as well as fine. Okay, what was the question? Frequency of each element of an array, right? So okay, let's declare the array. What will be the array? Who will tell? what array you want to check with to solve this problem. What array example you want? Give some example. Give some example. Who will give? Have some response. 5, 9, let's say 5, 4, 9, 5, 9, 5, 4, 9, 6, 6. Let's say this is my array. Okay. Let's say this is my array. What should be the output corresponding to that? What should be the output? 5 has occurred 2 times, right? 5 has occurred 2 times. Next. 9 has
also
occurred
2 times.
2 times. Next. 4 has
4
occurred
1
once.
time.
And
6 2 times.
fine. This should be my output that I should get. So let's see what Shazia has done. Okay. Let's run over my array. Okay. For I in a range length of array. Okay. So let us initially define count to be 0. That okay. Let me show you first. Okay, what has happened? See, this is my array. 5, 9, 5, 4, 9, 6, 6, right? Okay, fine. Let us start iterating from here. Let me initialize my variable I at the 0th index first. I want to count how many times 5 has occurred inside my entire array. What I can do, who will tell? What I can do? Starting from, I will initialize another variable j here. J will start at position I. Starting from I, what I will do, starting at I will check the rest of the array. That how many times this 5 has occurred. This 5 has occurred. And I will, for each value of I will initialize a count variable. That will be initially 0. Okay. Now I will check how many times array of j is equal to array of I. How many times? If this condition satisfies, I will increment my count by 1. Okay, I will start. J starts at I. This is, and I is at 0th index. J will start at the ith position. I is at 0. J will start at 0. Okay. Is now. Let us check. Is array of I equal to array of j? This condition is true. When j is at I, j starts at I. At when I is 0 and j is also 0, is array of I equal to array of j? This condition is true. This is true. Let's increment. Let us initialize count to be 0 initially, and whenever this condition is satisfying, let us increment my count by 1. Okay, now okay, this part is done. Increment j by 1. Increment j by 1. Increment j by 1. Now again I will check. Is 9 equal to array of I? False, right? Just move my j one step ahead. Again, is 5 equal to array of I? 5? True. Increment count by 1. This is done. Fine. Again, keep on incrementing values of j. Is array of j equal to array of I? Is 4 equal to 5? No. Increment j again. Is array of j, that is 9, equal to array of 5? Sorry, array of I, that is 5? False. Increment j again by 1. It is at 6 now. Is 6 equal to 5? No. Increment j by 1 again. Again, is 6 equal to 5? No. Do what? Increment j, and j comes out of the indexes of array. So at this time, my jth loop breaks. At this time, my jth loop breaks. So final count of 5 final count I wanted to print for array element 5 is 2, which is correct, right? I will print element is 5. It has occurred 2 number of times. Okay, fine. Now increment. When this j has stopped execution, increment the value of I by 1. Now I will point at this 9. Now again initialize j where I is right now presently and continue the same process. Let me do it for you inside the code. Then I think more clarity will be coming. Okay, initialized count at 0. Now what I will do? Initialize j at I, and that will go up to length of array minus 1, right? So what I will do, if array of I equals array of j, this condition is true. If this condition is true, increment the value of count by 1. Increase value of count by 1. Okay. And after this part is done, after entire counting is done, how many times ith element of array is present inside my array? Okay. How many times the ith element of the array has occurred inside my array? Print the ith element of array as well as the count. That's all. Now let's see by this method what result we are getting. What result we are getting. Okay.
Sir, I did it a little bit differently.
Yes, I know. Just I want to show them the output. By this method, what output we are getting. See all of you. What output we have received here? See, at first 5 is 2. What is my array? What is my array? 5, 9, 5. 4, 9, 6, 6, right? So I starts from here. I will go from where to where? I will go from 0 to length of array minus 1. What is it? Length of array minus 1, 6. From 0 to 6, value of I will go. For each value of I, we will have a j pointer. And for each value of I, we will have count that has an initial value 0. Okay, first, let's start. Is array of j equal to array of I? Come inside the jth loop. If array of j equal to array of I, is it true? I points at the 0th index. Initially, at first, I points at the 0th index. J will start at 0. Is array of I equal to array of j? True, right? Do what? Increment count by 1. Now increase j by 1. Increase j by 1. Is array of j equal to array of I? True or false? Array of j equal to array of I? True or false? False. Do what? This condition is false. Skip this line. Go back to the jth loop. Increment j by 1. J comes to now this 5. Is array of j equal to array of I now? True or false? True or false?
True, sir.
What will happen? Increment count by 1. Increment count by 1. Fine. What will happen next? Increment j by 1. Increment j by 1. Array of j equal to array of I. True or false? 4 equal to 5. False. This condition is false. Skip this line. Go back to the for jth loop. Okay. J increases by 1. Is this 9 equal to 5? True or false? False. Again, do what? Just increment j by 1. 6 equal to 5? False. Again, increase j by 1. 6 equal to 5? False. Increase j by 1. J comes out of the array. J points out of the array because value of j now becomes 7, right? So this jth loop now terminates. Print array of I, print array of I and count. What is my I? Where is my I pointing right now? Where is my I pointing? At 5, right? And what is the value of count I have? 2. So what I have printed? 5, 2. How many times 5 has occurred? 2 times. Have I printed it correctly?
Yes, sir.
Okay. Now next. Okay. How many times array of 0 has occurred? How many times whatever element is present at array of 0 that has occurred inside my array, I have successfully counted that. Am I correct? Am I correct? How many times value that is present at array of 0 that has occurred inside my array has a, okay, I have successfully counted that. Am I correct?
Yes, sir.
Yes, sir.
Okay, now let's see what will happen next. After printing, what will happen? Who will tell? Loop will go back to I. Am I correct? Loop will go back to I.
I get 1 then.
And value of I will be incremented by 1. Where was I pointing initially? Where was I initially
Initially
pointing?
5, then
Next, I will be pointing at this 9. Am I correct? I will now point.
Yes, sir.
Yes. Value of I was 0. It will be 1 now. It will be 1 and I will be pointing at this 9. Now again, where J will be pointing? Okay, I has got value 1. It will initialize again, count for itself, right? Count now will be again reinitialized to 0. It will come inside the Jth loop. J will be initialized at the value, at the position where I is pointing. J is initialized. Now what will happen? For J in range I to length of array, starting value of J is equal to I, and that will run until value of J to be length of array minus 1. Till this value, Jth loop will run. So, okay, it will check if array of I equal to array of J, array of I equal to array of J, what will happen? Array of J points at 1, I also points at 1. Array of J equal to array of I, true or false?
true.
So, what will happen? If this condition is true, come to the next line, count plus equal to 1. That means increase the value of count variable by 1. Done. Go back to the Jth loop. Go back to the Jth loop. Now what? J will be increased by 1. J is increased by 1. What will happen? What will happen? Again, 5 and 9 will be checked. Array of J, is array of J equal to array of 5? 5 is equal to 9? False. This condition will be checked. If array of J equal to array of 5, this is false. Skip this line, go back to array of J. Go back to the Jth loop, sorry. So now J points to this 4. J increases by 1, it points to this element 4. Again, check 4 and 9. Are they equal? Array of J equal to array of I? False. Skip this line, go back to the loop. J increases by 1. Again, see. Is this 9 equal to array of I? True or false? Is this 9 equal to array of I? True or false? What will happen? If array, this condition is true, array of J equals array of I, count increases by 1. Count increases by 1. Value of count variable now becomes 2. Fine. Now again J increases by 1. 6 equal to 5. 6 equal to 9. False. Again increase J by 1. 6 equal to 9. False. So final value of count is 2. This loop will now terminate. Print array of I and count. What is array of I? What is array of I?
9.
So I have printed 9 and 9 has occurred exactly 2 times inside my array. Am I correct or wrong?
Correct.
So, okay, fine. Next, what will happen? Who will tell? Next, what will happen?
So next I goes to the goes to 2.
It is 5, right? It's not 2. Value of I,
5.
exactly.
Sorry.
Yeah. It will come back to the ith loop. Value of I becomes 2. That means I points to this 5. But one thing, have you noticed? This 5 was already counted, right? Do I need to print something
Yes.
5, 1? because 5 is already have been counted. We have already printed 5 and 2. This output is already there. Why? Because 5 has occurred twice in my array. So do I need to again count for this second 5?
No, sir.
This is not required, right? I should not point here because this is already a part of this 5. So what shall I do here? This is what Shazia has done brilliantly. Okay. Let's do one thing. Okay. Whenever we are counting, my array was what? 5, 9, 5, 4, 9, 6, 6. We have counted when I was at 0, we have counted both the 5s. Correct? We have counted both the 5s. That's why my output was 5, 2. Let's do one thing. Once or any of the element is part of the count, okay, let's mark them as -1. Let's mark them as -1. That okay, this thing will not be counted anymore. This -1 indicates that this element will not be counted anymore. So let's do one thing. Let's put a condition here. Let's put a condition here. Let's put a condition here that if array of I equals to -1, let's not count it anymore. Let's not count it anymore. Okay. Done. Now let's see what my output is coming. Okay, and inside the jth loop, what I will do, if array of I equal to array of j, count I will increase, and along with that, I will mark array of j equal to -1. Nothing else. Now let's try printing. What my result is coming. Sorry. This not will be equal to, this will be minus, not equal to. Okay, what's the case? Not equal to -1. Okay, fine. One issue is coming. Let's initialize our count as 1. And let's start checking from I plus 1. Okay. Okay, is it coming fine now? 5 2 times, 9 2 times, 4 1 4 1 6 twice. Is it coming correct now? Is it coming correct now? What we have done? What we have done?
Yes, sir, it's correct.
Okay, what we have done? What we have done? 5 9 5 4 9 6 6, right? Let's I starts at 0. I starts at 0. Okay, for this I count, let's initialize count as 1. That okay, whatever element I have inside this slot, okay, for that I will be checking for the rest of the array elements, right? Whether any of the array elements from I plus 1 to j, that is equal to array of I or not. This is what I will check. So just already include this occurrence inside my count. And do what? Initialize j at I plus 1. Now start checking from the next slot. Okay, now start checking from the next slot. Start checking. That's why I've done what? First, I will check if array of I not equal to -1. Is this 5 initially -1? 5, 9, 5, 9, 9, 6, 6. It is 5 only. It is not equal to -1. So what? Do what? Run a loop. For j equal to I plus 1. From I plus 1 to length of array -1, run a loop. Now just check if array of I equal to array of j. Is this 9 equal to array of I? Is this 9 equal to array of I? False. Do what? Skip these lines, go back to the loop. Increase value of j by 1. Increase value of j by 1. Is this 5 equal to 5? True or false? Is this 5 equal to array of I? True. Increase count by 1. It becomes 2. Again, increase value of j by 1. 4 equal to 5? False. Increase value of j. 9 equal to 5? False. 6 equal to 5? False. 6 equal to 5? False. So at the end, what is the value of my count? 2. What was my array of I? 5. Do what? Print them. 5, 2. 5 has occurred 2 times. This part is done. Okay, fine. Next, go back to the loop. Go back to the loop. Go back to the loop. I now comes here. I points to this 9. Okay. For this I, create a count variable that is initially 1. Okay. Include the occurrence of this 9 at the ith position already inside my count. Okay. Now start. Now I will check. Is this 9 equal to? Okay. Missed one point. Just give me. Five, 9, 5, 4, 9, 6, 6, right? So we started at I equal to 0. J started for I equal to 0. J started here. This 9 was not equal to 5, right? So just increase this J to the next position. Now see inside the jth loop, see if array of I equal to array of J, is this 5 equal to the array of I? Is array of J equal to array of I? This condition is true, right? When J is here and I is here, this condition is true. So what will happen? Count was initially 1. Count was 1. Increment value of count by 1. And then do what? Array of j equal to -1. Mark this element. Update this element to -1. This is what we have missed. Done. This 5 was equal to array of I. So what we have done? Increased our count and marked array of j as -1. Whatever is inside array of j, mark that as -1. Fine. None of the elements after this 5 is equal to 5. So for all of them, this condition is false. Okay. Jth loop will do nothing, but will stop execution once its value comes out of the loop. Okay. This. And I will be printing the value 5 first. Next, what will happen? This value has now been marked as -1. Now I will come here. I will come at this position, at the second position. Is 9 equal to -1? Is this condition true? If array of I not equal to -1, this condition is true, right? Come inside the jth loop. Initialize count by 1. Come inside the jth loop. And now mark j from I plus 1. Start the jth loop from I plus 1. I is here. Jth loop will be starting from I plus 1. Okay, fine. This element is -1. Is it equal to array of I? False. Increase j. Is array of j equal to array of I? False. Increase j. Now see, 9 is equal to 9. Array of j equal to array of I. This condition is true. Array of I equal to array of j. This condition is true or false? When j is pointing here and array of I is pointing at this position, array of j and array of I are equal. So come inside. Increase count by 1. It becomes 2. Increase count by 1. Array of j equal to -1. Whatever is present at array of j, update that to -1. Done. Okay, again, increase. This will go back to the loop. Increase value of j by 1. Is this 6 equal to array of I? 9? False. Increase j by 1. 6 equal to 9, again false. Now j comes out of the loop. Value of j comes out of value of j now becomes equal to length of array. That is equal to the stopping point of the jth loop. So the loop here terminates. Print array of I count. What was my array of I? 9. What is the count I have got? 2. Print 9. Fine. Now what will happen? It will go back to the ith loop again. The outer loop it will go back to. What will happen now? What is my array? What is my updated array that I am getting? 5, 9, -1. Then 4, -1, 6, 6. This is my array. My array I points here now. My value of I, variable I points at this -1 now. So what will happen? Okay, since ith loop is running, count will be initialized. Count will be initialized. But this condition will be checked. Let me wipe out. But this condition will be checked. If array of I not equal to -1, is this true? Array of I, when I points at this -1, array of I not equal to -1, is this condition true or false? So what will happen? This entire block will be skipped. Since the print array of I count is inside this if condition, entire block will be skipped. It will go back to the ith loop, nothing else. I will be increased by 1. I points at this 4. Okay, now again count will be reinitialized to 1. Check this condition. If array of I not equal to -1, is this true now? Array of I not equal to -1, is this true? Array of I is 4, not equal to -1. So do what? Run the jth loop. Jth loop from I plus 1 to length of array -1. Now see, -1 equal to 4, false. 6 equal to 4, false. 6 equal to 4, false. What is the value of count I am having? 1. So what will be printed? What will be printed? 4 has occurred 1 time. Successfully printed, right? Fine. Now next, go back to the ith loop. I points here. Initialize count to, reinitialize count to 1. Okay, this part is done. Now, if array of I not equal to -1, is this condition true? Is this condition true? When I points here at -1, is this condition true?
No, sir.
What will happen? Entire block will be skipped. Go back to the ith loop. Value of I increases by 1. Value of I increases by 1. Okay, fine. I points at this 6. Initialize count to 1. Reinitialize count to 1. Check if array of I not equal to -1. Is this true now?
Yes.
What will happen? What will happen? Start jth loop from here. Start jth loop from here. J will be starting from I plus 1 to length of array -1, right? J starts at length. J starts at I plus 1, ends at length of array -1. So what will happen? This condition will be checked. Array of I equal to array of j. I is here. I is here at this 6. J is here at the last 6. Is this condition true? If array of I equal to array of j. Is this condition true? So what will happen? Increase count by 1. Increase count by 1. Count becomes 2. And what I have to do next? Mark array of j. Mark array of j to be -1. Mark array of j to be -1. 6 becomes -1. Fine. And then it will come back to the jth loop. Sorry, it will come back to the jth loop. Value of j becomes equal to length of array. That is the stopping point of my jth loop. So the loop terminates. print array of I and count. What I will print now? What is array of I? I points here at this 6. What is the value of count? 2. Print 6 and 2. Successfully printed. Next, what will happen? Go back to the ith loop. After printing this, go back to the ith loop. Go back to the ith loop. I will point here. I will point here at the last 6 is, and now this has been marked as -1. The last 6 is now marked as -1. Updated. This value has been updated to -1. Initialize, reinitialize count variable to 1. Fine. Reinitialize the count variable to 1. But yeah, after now check if array of I not equal to -1. Is this true? Last element has been updated to -1, right? So is this condition true? This is false. Skip the entire block and go back to the ith loop. So now value of I becomes equal to length of array, right? Value of I becomes equal to length of array. This ith loop terminates, and finally this is the output that I am getting: 52924162. Getting it? How we have done? How we have done? Getting it?
Yes.
Please tell me. Using 2 loops. Okay, who will tell the time complexity of this problem? Using this method, what is the time complexity? Who will tell?
So n square.
Yes, n square, definitely.
Big O.
How is it coming to be big O of n square? What is the worst case scenario? Worst case. Who will tell? What is the worst case scenario? What is the worst case? In this method, what will be the worst case? When all elements are present inside the array only once. Am I correct? When all the elements present inside the array have occurred only once. So what will happen for this one? I will check the rest of the elements, right? For this 2, I will check the rest of the elements. For this 3, I will check all the elements towards its right. So how many checkings I am doing? For 1, let's suppose for the element 1, how many checkings I will do? For this one,
n minus 1.
n-1 checkings I will do, right? Because this 1 is not equal to -1, right? This one initially is not equal to -1, and none of the elements towards the right of 1 is equal to 1. None of the element towards the right of array of 0 is equal to it. So nothing will be marked as -1. Nothing will be marked as -1. What will happen? How many checkings I am ending up with? For array of 0, n-1. Similarly, for element 2, how many checkings I will do? n-2.
N-1.
n-2.
Sorry, N-2, sorry.
For this 2, I will check 3, 4, 5, 6 all. I will check 3, 4, 5, 6 every element. So how many checkings I am doing? n-2. For element 3, how many checkings I am doing?
N-3.
n-3. Then for element 4, n-4, right? Element 5, n-5, and element 6, n-6. So what I can say is that let's simplify it. Let's simplify it. What we can say that for 1, we are doing 5 comparisons. For 2, we are doing 4. 3 comparisons. 4, 2 comparisons. 5, 1 comparison. 6, 0 comparisons. So total number of comparisons we have done 5 plus 4 plus 3 plus 2 plus 1. Can I say for any element, any array of n elements with all elements unique, I will say it will do exactly n-1 plus n-2 till 0 comparisons. Can I say this? Or we can say it will end up, the last comparison will be 1. For the for the second last element, I will be doing the last comparison. So total number of comparisons that I am doing is total number of checkings, these operations. If array of I equal to array of j, increase count by 1, and array of j equal to -1. So effectively, these things won't be there, right? If all the elements inside my array are unique, that is, no element occurs twice. More than once, no element occurs. these conditions will never be executed. And only I will just compare elements, whether any of the array element j is equal to array element I or not. So how many total number of comparisons I'm ending up with this method? Summation of n-1 plus n plus n-2 plus till 1. So what is the value of it? Who will tell? N into n-1 by 2,
into
right?
n plus 1.
N into
Yes,
n-1 by 2. It starts at n-1. See. So what is the time complexity? Big O of n square by 2 minus n by
big
2.
O.
Neglect. What is at the end? Big O of n square. So this method gives me time complexity of big O of n square. Any doubt till here? Tell me. This is the brute force approach, the worst approach that I can have. And this will be giving me time complexity of big O of n square. Okay, fine. But one thing I can do, I can use a dictionary. Yeah, Kanu, unmute. Worst case, what will be the worst case array? What will be the worst case array when each element occurs exactly once inside the array C? 5, 9, 3, 4, 2. Okay. So for this 5, I will check rest 4 elements. Rest 4 elements I will check whether any of the element equal to 5 or not. How many checkings I have done? 4 checkings, right? And for each checking, I have not executed any of these lines. Why? This condition was false. So none of these elements will be marked -1. Correct? If any of the elements towards the right of 5 equals to it, then only we say that, okay, this will be counted with this 5 only, and that element will be marked as -1. But for this particular array, this condition is not true. So we do exactly 4 checkings with no elements marked as -1. Again, I increases by 1 for this 9. How many checkings we do? How many times this condition executes? 3 times, right? 3 times. J will start here, J will end here. 3 comparisons we will do. Again, when I increases by 1, what will happen? When I increases by 1, J will start here, J will end here. 2 comparisons we will be doing. When I comes here at the second last element, J checks only, the Jth loop will only check for this 2, whether this 2 is equal to 4 or not. 1 comparison we have done. And for this 2, no element is left to check. So, okay, loop terminates. How many comparisons we have done? 4 plus 3 plus 2 plus 1. Total number of, so for any general array, with all elements unique, what we can say, total number of comparison is n-1 plus n-2 till 1. So what is the sum of it equal to? What is the sum? N into n-1 by 2. So what is the time complexity? We go of n square by 2 minus n by 2. Neglect this. Lesser power of n, neglect. This 2, neglect, constant. What is the time complexity? We go of n square. Getting it? Getting it? Tell me now. Got it? Fine, this part is done. I have solved this problem successfully using brute force approach, that is using 2 loops. But yeah, this problem can be solved. This problem can be solved in big O of n time by something we call hashing. But how? Any idea? Any idea? How I will do that? This is the brute force approach. How will I do? Hashing. So let's declare a dictionary. How we declare a dictionary? Who will tell? How do we declare a dictionary?
Key value
No,
D.
no. Let's let the dictionary be D. Okay. How do we declare it?
D.
Curly brackets. Correct?
Curly
Correct or
brackets.
wrong?
Yes, sir.
Fine. Okay. Now let's try. Let's run over the loop. Let's run over the array. Sorry. For I in range, length of array. What will happen? Just check a condition. If array of I in D dot, what is the key function? How do we use the key function? How do we utilize the key function?
So, dot key bracket open close.
This one. Am I correct?
Yes, sir.
So if array of I in D dot keys, if array of I is a part of keys of my dictionary, do what? Increase the occurrence of array of I by 1. Increase the value or the occurrence of array of I inside the dictionary by 1. Else do what? Else insert array of I inside my dictionary and mark its first occurrence as 1. Done. This part is done. Okay. And our entire code is also done. Let's print the dictionary itself now and see what result we are getting. Correct. Getting the correct result 52924162. 52924162. Am I getting the correct result? Am I getting the correct result? Who will tell the answer? So what I have done? What was my array? What was my array? 5954966, right? 5954966, right? Initially, before any loop is starting, this dictionary was empty. This dictionary was empty. No key, no value inside it. No key, no value inside it. Dictionary was empty. Okay, fine. Let's start running the loop. I in range. I starts at index 0. If array of I in D dot keys, is this true? Array of I is present in dictionary dot keys. Is this true? Is this condition true? 5 is present in any of the keys of my dictionary D. False. So do what? Insert a key 5 inside the dictionary and mark its value to be 1. It has occurred once inside my array. Okay, D of array of I equals 1. Mark its occurrence as 1. Mark the occurrence of element 5 inside the dictionary as 1. Fine. Go back to the loop. Go back to the loop. Okay, 9. I comes here. Now tell me, is this condition true if array of I in D dot keys, any of the keys inside the dictionary equals to 9? Is it true? Only one key is there, right? Right now inside the dictionary, that is 5. So none of the keys inside my dictionary is equal to 9. Do what? Do what? Skip this line, come inside the else condition. D of array of I equal to 1. Insert the key 9 and mark it has occurred once inside the array. Mark its value to be 1. Okay, done. Now we have two keys inside our dictionary, 5 and 9. 5 has a value 1, 9 has a value 1. Done. Go back to the loop. Value of I increases by 1. Again, if array of I in D dot keys 5 is equal to any of the keys inside the dictionary, is this true or false? Is this true or false? Is this true or false?
Is it true, sir?
This is true, right? So do what? D of array of I, whatever value this key is having, increase that by 1. It becomes 2. Skip the else part, because if was true, go back to the for loop. Value of I increases by 1. Check again. 4. If array of I in D dot keys, 2 keys we have, 5 and 9. Any of the keys equal to 4, false. Skip this if block, go inside the else condition. D of array of I equal to 1. Insert key 4 and mark its value to be 1 inside the dictionary, right? Go back to the for loop. Okay. Again, I points to this 9. See. Again, come inside the if condition. If array of I in D dot keys, any of the key inside the dictionary equal to 9, true or false? 3 keys we have inside the dictionary, 5, 9, and 4. Any of the keys equal to 9, true or false? True or false?
True.
So what will happen? What will happen? Come inside this D of array of I plus equal to 1. That means whatever value this 9 is having, whatever value this 9 is having, increase that by 1. 2. Done. Skip the else part. If condition was true, go back to the for condition. Sorry, for loop. I now points at this 6. Any of the keys, now check, any of the keys inside the dictionary equal to 6, true or false? True or false?
True, sir.
True. Any of the keys inside dictionary equal to 6, true or false?
False.
False, right? 5, 9, and 4. 3 keys we have. None of them equal to 6. So do what? Come inside the else condition. Insert key 6 and mark its value to be 1. Go back to the ith loop. And now I points to the last element. Now see. We have 4 keys inside our dictionary. 5, 9, 4, and 6. Check the if condition. Array of I in D dot keys. Any of the array elements, sorry, any of the keys of my dictionary equals to 6. Is it true?
True.
What will happen? Come inside the if condition. D of array of I plus equal to 1. Increase value of this key 6 by 1. So what is my final dictionary looking like? What is my final dictionary looking like? 5, 2, 9, 2, 4, 1, 6, 2. This is my final dictionary. Am I getting the same dictionary as my answer? Am I getting the same dictionary as my answer? Getting or not?
Yes, sir.
Okay, fine. So are they? 5 has occurred twice, 9 has occurred twice, 4 has occurred once, 6 has occurred twice. Is the occurrence that I have counted? So have I counted it correctly? 5 is the key. Number of time it has occurred equals to 2. This is the value. This is the key. This is the value. Key represents what is the array element. 2 represents how many times it has occurred inside the array. So I have counted them correctly. 5 has occurred twice, 9 has occurred twice, 4 has occurred once, 6 has occurred twice. Have I counted it correctly? Counted it correctly?
Yes, sir.
So what is the time complexity of this? Who will tell?
Big of n.
What is the time complexity? What is the time complexity? How many times the loop is running?
Big O and
N times.
If n is the length of the array, how many times it is running? N times. Okay, fine. I may ask you one question. What about this? I am also checking inside the dictionary, right? I am checking inside the dictionary also whether an element is present inside the dictionary, whether array of I is present in the dictionary keys or not. What is the time complexity of this function? Who will tell? Dictionary may have n keys, right? Dictionary may have n keys inside it. It may have n keys inside it, and I have to check among n elements, which of the key is equal to array of I. So again, will I say the time complexity here also is big O of n into n square? No, never. Remember one thing. Whenever we do hashing, we know that if I search for a key inside the dictionary, I will be able to fetch that in big O of one time. Inside a dictionary, if you search, most of the time, majority of the time, the searching will be done in big O of one time. Can you remember that? This is the major reason why we do hashing, because we will fetch the element. Okay, we will search the element inside the hash map or inside the dictionary in just big O of one time. In no time we are able to search. That's why. Okay, that's why this hashing will not change the time complexity. How many times?
So why it is big O of 1?
That is the property of dictionaries. Okay, your dictionaries are made in such a way such that it satisfies this property, that yeah, I will be searching my element inside or key inside a dictionary no more than big O of one time. Else dictionaries have no meaning. Dictionaries are meant for that only, that yeah, inside it I will be searching for a key with in no more than big O of one time. Okay, that's why your dictionaries are made. Fine. So what we are doing, we are running the loop how many times? N times, right? And for each of the n times, I am searching for a key. So that takes only one operation. Searching for a key roughly takes only one operation. So what is my time complexity? Big O of n into 1. Am I correct? So what will be my final time complexity? Big O of n. So see, the brute force approach that we have done have given me time complexity big O of n square, and we have reduced using hashing our time complexity big O of n. Got the difference? This program is much faster than what we have done using brute force approach. Got it? Tell me that. Pakka? Sure. Okay, fine. One thing I can ask, okay? The array we are using, that is for taking the input, right? Array has the inputs given by the user. Am I correct? Am I correct? Whatever input I will be having, I am putting that inside an array that has input data. Correct or wrong? Now see, I am using dictionaries also. This dictionary I am using separately. For storing the key value pairs. Am I correct? Dictionary separately I am using to store how many times an array element has occurred inside my array separately in the form of key value pairs. Okay, such that 5 has occurred twice, 9 has occurred twice, similarly all other elements. So how many data we are storing here? In worst case, how many data we will store here? Inside the dictionary also, we can have in data, right? Suppose that this is my array. 1, 2, 3, 4, 5. All elements are occurring exactly once. How my dictionary will look like? How my dictionary will be looking like? 1 has occurred once, 2 has occurred once, 3 has occurred once. Now next, 4 has occurred once, 5 has occurred once. Am I correct? So what we can say, this dictionary has n keys. Am I correct or wrong? this dictionary for this particular array is having n keys and n values. Am I telling correct? For this particular case, 1, 2, 3, 4, 5, the dictionary that I will make will have n keys and n values. Am I correct or wrong? Have some response.
Yes, sir, correct.
Only one is telling. Tell me, please. Is it true that, yeah, this dictionary will have n keys and n values when all the elements inside an array will be occurring just once, only once inside the array? The dictionary too will have n keys and n values. Correct? So now see, apart from, for taking the input, we have some data structure array, right? A data structure array we have. But we are using some extra memory also, right? Some extra data structures also to maintain our data in the form of key value pairs. Am I correct? Some extra data structure also I have used here to maintain my data, array data, in the value of key value form, key value pairs. So can I say that, okay, apart from taking the input, this is the input I have to take mandatory, but I am using n extra memory, n amount of n slots of extra memory, n slots of extra memory to solve my problem. Am I saying that? If length of the array is n, okay, I am using n extra slots of memory. This is my memory, okay. This some part is allotted for the input, some part is allotted for the input, but among these I will use this one, this part of memory to store my dictionary. Some extra n slots I will use. Okay, so I can say that, okay, I am using n extra slots of memory. This will contribute to something called space complexity of my problem. Whatever extra memory you use falls under space complexity of my problem. Space complexity means what? What is the amount of extra memory you are using to solve your problem? Extra memory. Array I have used, but that's a part of input. You may not consider that for my space complexity, that you may not consider, but whenever I will be taking some extra memory, such that likewise I've used this dictionary, and in the worst case that will have n extra slots of data, that will have n data, exactly n keys and n values, that will occupy n extra slots inside my memory. So that will give rise to something called space complexity. Space complexity means what extra slots of memory among the allotted memory, what extra memory you have used to solve the problem. So in my case, since I am using n extra slots of memory, I will say that, okay, big O of n is my space complexity. Tell me, getting this? What is space complexity? What is the extra memory you have used to solve your problem? In my case, for the hashing problem that we have solved just now, we are requiring to store exactly n keys and values inside my dictionary. So we are using n extra slots of memory from the allotted one. So that is giving rise to something called space complexity of my problem, that is equal to big O of n. Why? Because I have used exactly or roughly n slots of extra memory. Tell me this, is it clear? What is space complexity? And for this problem, what is the space complexity? Is it clear, or you are having any doubt? You can ask.
So what is the space complexity of brute force?
No space complexity extra we have, right? We have just only one input I have. extra any memory you are using, any other extra list you have declared, any other extra dictionary or something else you have declared? No, right? I have just run the loop. Nothing else I have done. Over this array only I have run the loop and I have calculated my result. Nothing extra list, no extra memory, no extra memory variable or and all will contribute to the space complexity. Something that we have done is, okay, we have declared this count variable, okay, but single variables contribute to big O of 1 space complexity. This is negligible. This is negligible, not counted. But yeah, along with the array, had you declared another list to store the results, or something like that, that would have given you space complexity of something big O of n or something else. But since I am just running the loop over the same array, I am just running the loop and printing the results. No extra space I require. So the space complexity for brute force approach is big O of 1. No extra space I am requiring. But for the hashing part, I require to store my data inside a hash map. In worst case, that has n extra data. And that occupies exactly how much? N slots from my given memory. So we have something called space complexity that will rise to big O of n in case of hashing. Okay. Getting it? Tell me any doubts you are having. Any doubts, anything else you are having?
ज्यादा प्रेफरेंस किसको देना चाहिए, स्पेस कॉम्प्लेक्सिटी का टाइम कॉम्प्लेक्सिटी?
डिपेंड करता है स्पेस अगर यूज एक्स्ट्रा स्पेस, अभी ये पॉइंट्स ज्यादा क्लियर होगा जब डीपी में आएंगे, ठीक है, कि time complexity is very large, but in DP you will see with using some extra space, we can bring down our time complexity. Just what we have done here. The brute force time complexity was what? Big O of n square, large time complexity, but by using extra space big O of n, I have reduced the time complexity to big O of n. So definitely this method is preferable, right? This is much faster. Big O of n square is very much slower than big O of n. That's all.
So array also having n number of elements, then why it is 0 or big O of 1?
No, it is not big O of 1. This is not big O of 1. But array is a part of your input. This will be definitely allowed, right? Without input, how can you calculate results? So what is generally being done is that this input array is not considered to be part of space complexity. The input array, input variables are not considered part of space complexity in general. Whatever extra space you are using, that will contribute to your space complexity. Just remember this.
So in dictionary, we can't give inputs.
You can take the inputs, right, in the dictionary. But yeah, I am given the input in the form of array. And for calculating the result, I'm using an extra dictionary. I am given a sequence of numbers, and for calculating my result, I will be having a dictionary. This is not that I can't have. This is my problem, that I am given an array and I have to count the frequency. For that, I'm using a separate dictionary. Input array is different, dictionaries are different. So this is giving rise to a space complexity of big O of n.
Okay, sir.
Okay. Any doubts you are having? Please tell me. Please tell me. Else we will move to the separate problem, to the next problem. Any doubts? Please tell. So input array is given, right? Input array is given. Entire data I have, entire data given inside the array. I have done what? Stored it in a separate dictionary in the form of key value pair, right? Key value pair. What does the key value pair denotes? Key denotes what is the array element. What is the array element? Value denotes how many times it has occurred inside the array. So in worst case, what will happen? All the elements of my array has occurred exactly once, right? Exactly once. If this is the case, then what I can say is that inside dictionary, how many keys I will have? N keys. If length of the array is n, I will have exactly n keys and n values. So this input array has some memory requirements. This input array requires some memory to store the elements. But yeah, apart from this, I require some extra memory too, to store data in the form of key value pairs. How many data I will store? N keys and n values in the worst case. So what is the space complexity? What is the extra memory I'm requiring? Can be written big O of n. Getting it? Who is having doubt? Yeah, bolo.
सर इसका वर्स्ट टाइम कॉम्प्लेक्सिटी भी बिग ऑफ n है और बेस्ट केस भी
नहीं,
big of n.
worst time complexity is big O of n square in brute force. What is the worst time complexity?
So using this hash method.
Yeah, using hashing map, the worst time complexity is big O of n.
And the best case also is big of n.
Yeah, best case is also big O of n. Without big O of n, you cannot do this problem.
So sir, this is possible that the best case and worst
Yes.
case is similar.
Yeah, same. It is possible. Both best and worst case for this, it has big O of n time complexity. Best and
So
worst.
best case of brute force.
Now, best case of hashing. Best case of brute force is big O of n. Think of that, how it will come. Best case of brute force is big O of n.
So best case is it have only single element.
No,
Same
all
element.
the elements are same. All the elements are same, and this is the best case for
Yeah.
brute force. Best case for brute force. All the elements are same, and the time complexity for best case using brute force method that we have seen is big O of n. How this is your task to think. This is your task to think. Best case for brute force.
So it will run only one time.
Yeah, exactly. This will run not one time, but big O of n times. Exactly n times.
Exactly n times.
Fine. All done. Can we move to the next problem? Can we move to the next problem?
Yes, sir.
Clear with everything what we have discussed? Please tell me. Okay. Tell me, have some response, clear or not?
Yes, sir.
Akka. Okay. Let's come to a problem on strings. Okay. Let's say I have a string A, B, C, D, E, F, G. Okay. So now can anybody tell me this is a string? What do you mean by a substring? Substring. What do you mean by a substring? Who will give the definition?
A small part of a string.
Continuous
So
part of string.
continuous segment of.
A continuous segment of string. This is called substring. Suppose that B, B, C, D, D, all these things are what you call substrings. So how many substrings we have? How many substrings we have inside this string? Who will tell? Length of the string is 1, 2, 3, 4, 5, 6, 7, 8, 9. Length of the string is 9. So how many substrings we will be having? 9 into 9 plus 1 by 2. How many? 9 into 10 by 2. That is equal to 45. Okay. Your task is calculate length of longest substring. Longest substring such that the substring has no repeating characters. Okay. Understood the problem? No character should be repeated inside the substring. Substring should be such that, suppose that this BCD, no character is inside it that is repeated. All characters has occurred only once. But if I go to BCDD, D has occurred twice. So this substring will not be a part of my answer. Okay. You have to calculate length of longest substring. Length of longest substring in which no character has repeated. So yeah, think of this problem 2-3 minutes, then we will discuss how we will solve. Think of that.
So in this case, there are two longest substring. So it will calculate both of them. Hello, sir.
Any approach you can think of? Any approach? Who will tell?
Sir, 2 minutes.
Oh, sure, sure. Any approach? Anyone else can come up? Okay, what is the brute force? Who will tell? What is the brute force approach to solve this problem?
हेलो
सर आई और जे लेंगे, एक एक इंडेक्स बढ़ा के आगे चेक करते रहेंगे.
Okay, yeah, Kanu, tell me.
हाँ सर, ये एक स्ट्रिंग हम ले लिए, फिर आई ले लेंगे, फिर उसको क्या करेंगे, हम चेक करेंगे, फिर एक एम्प्टी डिक्शनरी क्रिएट कर देंगे.
Okay,
उसके अंदर हम लोग उसका अपेंड करते रहेंगे, जो कैरेक्टर रिपीट मतलब जो कैरेक्टर होगा उसको अपेंड कर देंगे, अगर रिपीट होता है तो वहां पे लूप एंड कर देंगे.
acha. Okay, see here. What will be the brute force? Who will tell? What will be the brute force? Brute force approach. Let's
सर
go
मैंने
ahead.
ट्राई किया मगर मेरे को थोड़ा सा एरर टाइप आ रहा है.
Just wait. A. It's a B, C, D. What was my string? What is the just first thing? D, E, F, G. What will be the brute force? Who will tell? Brute force approach.
So checking all the possibilities.
Yeah. So how will I check? How will I check the brute force approach? Checking all possibilities means what? The question demands longest substring. Am I correct? Longest substring. So what I can do? Generate all substrings, right? Generate all substrings. Am I correct? Check all possibilities inside brute force. All possibilities. All possible substrings. I will check. So for that, I need all substrings, right? So I will generate all substrings. All substrings I will generate. Next, for each substring, what I will do? For each substring, check whether any characters repeats or not. Whether any character inside it is repeated or not. Okay. Okay. If if no character is repeated, this substring can be a possible answer. Okay. If not, consider the longest among all all such substrings. Among all such substrings. First do what? Generate all substrings. For each substring, check whether any of its character has repeated or not. If not, you can consider that substring to contribute inside the answer. Okay, you can keep an answer variable separately. And if the substring I have checked has no character repeated, you can, okay, for the current value of answer that I am having, I can update that. I will check simply if answer is less than length of my substring or not. Length of my substring or not. If it is, update the answer to length of substring. Can I do this? Can I do this? Check all possibilities. Check generate all substrings. For each substring, check whether any character is repeated or not. And if no character is repeated inside the substring, whatever current value of answer I am having, just check whether answer is lesser than the length of substring or not. If it is, update the answer to length of substring. Can I do this? Who will tell? This is what the brute force approach works. We have seen another problem also like this, right? Another problem also we have seen like this. Correct or wrong? Which problem was it? Longest subarray. Longest subarray with all elements same, right? With all elements same. This is just a little bit variation of the same problem. Little bit variation of the same problem. But yeah, I can assure you, you cannot solve this problem that we are discussing just by 2 pointers. Just by 2 pointers, you cannot solve it. Can you do it? Who can code this problem? The brute force. This is your, again, your task, your duty to code this, the brute force approach. Okay. What we can do first, generate all substrings. Generate all substrings. Then for each of the substring, for each substring you have generated, check what? Any character of the substring is repeated or not. If none of the character is repeated, all characters inside the substring has occurred only once, do what? Answer will be storing length of the longest substring, longest possible substring with no characters repeated. So what I can do, I will check that, okay, if my answer is less than length of the substring, update the answer with length of the substring. This is what I will do inside the brute force approach. Shared you with the approach, come up with the code. Brute force approach, all you will code from now. Okay. This part is very necessary. For every interviews, you will, the first part that you have to come up with is the brute force approach. Okay. Come up how the brute force approach will be looking like and what will be the time complexity. Okay, now how the brute force approach is supposed to give time complexity of big O of n cube, big O of n cube. Just same that we have seen in the longest subarray with all elements in. Brute force approach will give you time complexity big O of n cube. Done. How is it happening? And what will be the code? This is your task, the brute force, to find the brute force. Now we will see. Now we will see how we can solve this problem using hashing. What was my taken substring? Taken string. A, B, C, D, D, E, F, G, right? Yeah. Okay, let's keep a dictionary. Let's keep a dictionary. And let's keep a dictionary here. Fine, let's start iterating. Let's start iterating from this character. Let's initialize a pointer I here. And yeah, using, okay, including this character A, what is the longest substring I can have? This is my approach. If I am to include this A inside my answer, what will be the longest substring that will be possible? Okay, this will be my approach. Fine. So let's keep another variable J here, right? And do what? Okay, this A is included in my answer. This A will be included in my answer. So do what? Add character A inside the dictionary, increment its occurrence by 1. Fine, done. Increment J by 1 step ahead. Increment J 1 step ahead. Now see A. This A is already included. This A is already included in my answer. Okay. My basic approach is using any character, using the ith character, what is the longest substring I can frame? Longest substring I can get with no character repeated. Okay, now see. I have already included, this is my answer. This is my answer substring, let's say. I have already included this A. And that's why how many times inside the substring this A is occurring, I will store that inside the dictionary. I will store that inside the dictionary. It has occurred already once. Now this J, increment my J by 1. Increment by J by 1. Can I include another A inside my answer substring? Can I include? The answer asks me, the question tells me to calculate a length of a substring with no character repeated. So I have already inside my answer substring included this A. Can I include this second A also? Can I include this separate? If I include it, there will be two A's. A will be repeating, right? So what can be the longest substring possible by including the first A? What can be the longest substring that I can make by, what can be the longest substring that I can frame or that I can make by including the first A inside my answer? That is equal to A, right? This A. So, okay, one substring I have got, one possible substring I have got of length 1, okay, of length 1, that can be my answer. This A, single A. Fine. Now let's do one thing. Okay, by using this A, I have got what is the maximum possible answer I can get. Now let's do one thing. Remove this A. Remove this A from my answer. Using the first A, I have already seen that this can be the maximum length substring that I may get. So, including it, I have seen exclude it now from the answer. Exclude it. Exclude it. That means increment my I by 1. Increment the I variable by 1. And now from the next day onwards, I will see from the second day, if I want to include, what I will do. Means what is the maximum length substring I may get. Okay, fine. So, okay, now since this A has been removed, the first A have been removed inside the dictionary, this A will be removed. A is not at all present inside my answer, right? So A will be removed from inside the dictionary from the dictionary. So, okay, I is pointing at the second day now. So let's start again iterating J from the point I is standing. Include the second day inside my answer. Include the second inside my answer. Now, increment J by 1. Increment J by 1. Now, J points at this B. Can I include this B inside my answer substring? Can I include this B in my answer substring? Can I?
Yes.
Yes or no? My answer substring has the second A inside it. Can I include the next character B inside my answer substring? I can, right? Because none
Yes,
of A or B will be repeated. Now increment J again to C. Can I include C also inside the answer substring? Can I include C also inside the answer substring?
Yes, sir.
Yes.
So let's include that. C is also included. Increment J by 1. Increment J by 1. Can I increment this D also inside the answer substring? Can I?
Yes, sir.
So what will happen? A, B, C, D. This is the answer substring till now. I have got such that none of the characters are repeated. Okay, increment J by 1. J comes to this D, this position D. Now tell me, can I include this second D also inside the answer substring?
No.
Why I cannot? Because if I include this second D also inside the substring, this D will be repeated. D will be repeated. Fine. Okay, so what was the state of my dictionary? If I include all the 4 characters A, B, C, D, A has occurred once, B has occurred once, C has occurred once, D has occurred once. All has occurred exactly once, right? None of the characters has occurred twice or more than once. All has occurred exactly once. Okay, just let me wipe out. A, B, C, D, F, G. Fine. My I was standing here and my J has gone to this position till this point. Okay, I cannot include this D. I cannot include this D such that it comes such that inside the substring such that it is the longest possible substring. So this ABCD is of length 4. I have got a substring that has included 4 characters ABCD of length 4, right? Of length 4. Is the length 4 substring better than the previous length substring A that we have got as my answer? ABCD has a length that is greater than the substring A. So do what? Update our length to 4. That okay, this ABCD is a better answer than A. So let's do what? Include this, not this, inside my answer. Okay, let's include this ABCD as my final answer. And let's remove this. This will not contribute anyhow because I have got a better answer. Fine, done. Okay, this second D cannot contribute to my answer. Fine. So I can say that A, B, C, D, D, all the 5. These are the 5 characters I cannot include together inside my answer string. Correct? So what I should do? I have to remove some characters from this answer, right? Remove some characters from this answer such that I can include this last D. This last D I want to include. If I want to include inside my answer, I have to remove some characters. Now tell me one thing. A, B, C, D. Okay. A, B, C, D, D. Okay. Suppose that I remove A from my answer. This was my answer. And inside that I include this D. I include this last D. If I remove A from my answer, B, C, D, D, is it a possible substring I may get? Is this substring satisfying the needs without repeating characters? Okay, so let's remove B also. Let's remove B also. C, D, D, will it satisfy the need? Again, no. C, D is continuously repeating. Remove this C also. D, D, will it satisfy the need? No. Remove this first D. Okay, now a single D is lying inside my answer. Can that be considered as a substring with no repeating characters? Can that be considered? So let's do what? Increment. J was standing here. One by one, just remove all possible characters from my dictionary. Okay, because maximum possible answer, maximum possible substring using these 4 characters is ABCD. I have got that. But if I want to go ahead, I will get another D. So I cannot have BCD, ABCDD I cannot have, BCDD I cannot have, CDD I cannot have, DD I cannot have. So to include, to check my answer that is possible with the second D, let's remove all 4 characters from my answer. Let's remove all 4 characters from my answer. Removed, I am left. So what will happen? I will move to this position, to this D. I and J will now again start at the same position. Done. So what is my final answer right now? ABCD, correct? And all the characters that were inside my dictionary are gone. None of them are into the consideration right now. The dictionary is again empty, and I and J both are pointing to the second D. Okay, both are pointing to the second D. So let's see. Yeah. Again, my answer will be, answer was initially ABCD. All the 4s I have removed. So answer is again, answer string is again empty. Answer string is again empty. Fine. So yeah, again, include the D, I and J. Let's initialize J again at the ith position and include the D inside my answer. Increment J by 1. Increment J by 1. Increment J by 1. Can I include this E inside my answer variable? Can I include? Can I include this E inside my answer variable? Such that none of the characters repeat? Yes, include that. Increment J by 1. Increment J by 1. Can I include F inside my answer variable? Yes. Increment J by 1. Can I include G inside my answer? Yes, I can. None of the character will repeat. Now J will go out of my string. Okay. None of the string substring is left such that it will contribute to the answer. None of the characters of this of my given string is left such that it will contribute to my answer. So I will stop checking here. I will stop checking here. Now see, final value of answer I am getting is DEFG. Is its length? Is the length of DEFG greater than 4? Better than 4? No, right? So you can update the final answer. You may not. But the final length, greatest length string that I am getting such that none of the characters inside it repeat is 4. This is my final answer. So what we will do? What we will do? What we will do? If I want to include this character, I will keep on searching. I will keep on searching towards it, right? And will add all the characters into the substring till the time I see that, okay, now no more character can be added, because if I add more characters, the characters will start repeating. The characters will start repeating. Okay. And using this, suppose this A I have included, I have formed largest possible substring using ABCD. Fine. None of no characters else. After this ABCD I have considered, I cannot add more characters to it. It is a substring, right? So you have to go continuous. Segment should be continuous. Correct? No more. This D I cannot add more to the answer. So what I will do now, whatever substring consideration this I have, whatever substring consideration I have, I will start popping them out one by one from my answer and will update the dictionary accordingly. Okay. And then I will check what was the length I was having. What was the length I was having of my possible answer, and will update that to the answer length wherever I am maintaining. Okay, the substring that is under my consideration right now, if that has a greater length than my current value of length, I will update. I will simply update. I will update the value of length variable to the length of the substring that I have inside my answer variable. That's all. Then again, I will start searching from the next D, towards its right, and will keep on doing the same process. Okay. For that, for checking that whether this D is occurring again or not, we require a dictionary. We can keep a hash of every character. A has occurred once, B has occurred once, C has occurred once, D has occurred once. Now, whenever D is occurring twice, D has already occurred inside it, right? If it is occurring twice now, if its value is becoming twice, do what? Start popping from the ith character. Wherever I is standing, start popping from the ith character till the time value of D or value of the character that is getting repeated becomes 1. Okay. And then accordingly frame your answer. This is what we will do inside this problem. Okay. Tell me, is the approach understood? What we are doing to solve this problem using hashing? Tell me that. What we are doing using hashing, is the approach understandable? What we will do, try including ith character inside our answer. If inside the dictionary, my string of I is becoming 2, string of J is becoming 2, what I will do, start popping from the ith character. This ABCD was there. This D, this character D I wanted to include inside my answer, but I cannot, right? Because D will repeat. I will start popping till the time value of D becomes 1. That's all. Nothing else. Is the approach understandable? Tell me. Have you understood the approach, what we have done inside this problem? Or any doubt you are having with the approach? We will discuss the approach only today. Tomorrow I will take the code. Tell me that. Any approach you are having? Any problem regarding the approach you are having? What we are doing? Have some response. The time is almost over. After coding, it will be more clear. But can you understand little bit what we are doing? How the approach is going on? What we will do to code? What is required to be coded? Try coding this also. Okay, first come up with a brute force. I will not say code this, I will code it tomorrow. Code this approach tomorrow. Okay. Till then, try understanding what is happening, because coding is the last part. Coding is the last part. Coding is the last part. If you don't understand the approach, there is no point of getting code. Okay. If the approach is not understood, there is no point of coding that. Okay. Any more doubts? Anything you are having? Please tell me. Any more doubts? Anything else you are having? So yeah, let's do the MCQs and then we will wrap up. Okay, given the first MCQ. Attendance I have created. Those who don't have, please mark. Those who don't have any doubts can mark your attendance and you can leave. Any doubts anyone is having, you can ask. Good night, all of you.